Hello, this is Soyoung. The paper I will introduce is Tracking and Modeling Subjective Well-being using Smartphone-based Digital Phenotype. As you can see from the title, the aim of this study is identifying people's subjective well-being from smartphone data. This work is done with Uichin Lee from KAIST and Kyungsik from Azu University. This presentation consists of background of the research, related research, research methodology, and the results and discussion. First of all, I will introduce the background of the research. As I said before, this study is tracking people's subjective well-being based on smartphone data. So I will first talk about what subject well-being is, and then present studies related to supporting subjective well-being with positive computing research. Subjective well-being is a concept that encompasses how individuals evaluate life with positive emotions. According to Diana et al., subjective well-being is defined as a person's cognitive and affective evaluations of his or her life. It has three components. First one is satisfaction with life, and second is positive and negative emotional balance. The last one is psychological prosperity, which means that a value and purpose of life and having optimistic for the future. Various studies of subjective well-being have shown that people with higher subjective well-being are healthier, have more income and social resources, and have better academic performance and work skills. As subjective well-being is an important individual and social factor, much research has studied ways of promoting subjective well-being. Specifically, in the field of information and communication technology, there are various studies to support subjective well-being as part of the positive computing study. Positive computing is the research area that encompasses human-computer interaction, psychology, and emotional computing, which aims to present ways to use computing to improve human well-being and productivity. For positive computing research, many studies have used smartphones as a medium for understanding human well-being and productivity. This is because smartphones are the most common tools that capture people's daily lives. It also allows researchers to understand people's activity, location, and sociality through sensors in the smartphone. In addition, audio data can help researchers to understand people's emotions. With smartphones being used as a new research tool, smartphones have made it possible for researchers to understand people's daily life patterns. And a new concept called digital phenotype has emerged. Digital phenotype means moment-by-moment quantification of the individual level human phenotype in situ using data from personal digital devices. I just introduced subjective well-being, positive computing, and digital phenotype. In the related work section, I will introduce more specifically what studies have been done to understand and measure mental health through smartphones as part of positive computing. There have been various studies to identify mental health based on smartphone passive sensing. We looked at the various studies and found that there were two main cases. The first case includes studies that try to identify the relationship between mental health itself and passive sensing, which mostly conducted correlation analysis. The second case includes studies of detection that try to predict and diagnose mental health conditions based on passive sensing, which mostly conducted machine and deep learning based analysis. The table shown here is summary of prior studies. We can see types of mental conditions such as bipolar disorder, stress, emotions. Also, I noticed the study methods such as correlation, regression, and classification, with the number of classes used in classification. I also noticed types of sensors used such as accelerometer, call logs, SMS, GPS, and so on. Lastly, I noticed the number of participants in the study, and the duration of the user study. Our studies have mainly covered bipolar, stress, and general mental health. The association study identified the relationship between mental health and passive sensing through t-test, ANOVA, and correlation analysis methods. There are some examples. First, strong correlation between stress levels and noise, social, moving, and sleep. Second is negative correlation between depression and social activities such as SNS use or calling. Last one is positive correlation between movement and happiness. Second, for detection, most studies have been conducted to determine the symptoms of mental health through the classification model. Examples include bipolar or not judgment, judgment of stress level, and detect whether depression or not. From prior studies, we have confirmed that mental health condition can be identified through smartphone passive sensing. Based on this, we tried to find a way to help subjective well-being with passive sensing. Specifically, subjective well-being is a concept that includes both positive and negative effects. They need to be considered together to better understand and find ways of supporting subjective well-being. Considering both sides of subjective well-being has a benefit on understanding characteristics of each because we can track which factors influence positive or negative aspects. We can also leverage the notion of undoing effect, meaning that positive emotions might correct or undo the after effect of negative emotions. Based on this, we can make suggestions of factors of the positive effect when a user's negative effect increases. Next, I will talk about methodology. This includes research contributions, primary goals, data collection, feature extraction, and analysis. Our study consists of 3 stages: data collection, feature extraction, and analysis. Through this, our goal is to see a possibility of supporting people's subjective well-being via smartphone-based data. This slide shows data collection. First, we asked the participants to answer the questions about gender, self-esteem, positive psychological capital, smartphone addiction, and other health-related questions. They were collected before the study started. Second, we developed the app that runs background and collects people's movements, locations, and usage logs, screen on-off data through smartphone passive sensing. We asked the participants to install the app on their smartphone and used the app performances. During the app use period, we asked the participants to complete the survey about subjective well-being scores every day on their smartphone. After the study ended, we extracted features for modeling. The features we derived were divided into real life and smartphone life. Real life features include the ones that literally represent real life, such as movement, location, and sleep. Smartphone life features include app usage and daily smartphone usage time that can represent life in a smartphone. After deriving real life and smartphone life features from the smartphone log data, we conducted 2 primary analyses. In phase 1, we used the hierarchical regression analysis method to determine how real life and smartphone life features affect the participants' subjective well-being. Using the hierarchical regression method, we derived 2 models. Model 1 was developed based on the user attributes such as self-esteem, personality, and Model 2 was developed based on the smartphone passive sensing features, while controlled for the user attributes used in Model 1. In Phase 2, we examined the change of subjective well-being by applying a classification model. Our classification model determines 3 types of subjective well-being changes, which are the increase, decrease, and no change. The change of subjective well-being refers to the difference between 2 sequential subjective well-being values. From now on, I will present study results for each phase. This table shows the result of the hierarchical regression model. If we see the adjusted R-square result, there is 6% increase from model 1 to model 2. This indicates that individual attributes showed strong influences on subjective well-being, yet smartphone data still showed impacts on subjective well-being. Overall, subjective well-being is greatly influenced by individual characteristics. This motivated us to build user-independent models for classification, which was done in phase 2. From user-independent classification models, we found that max F1 macro score was 70% and mean score was around 15%. The average of F1 macro score from all independent models was 38%. Considering the fact that subjective well-being is highly influenced by individuals in the previous regression results, such a F1 score was not particularly impressive. However, given that there are participants with reasonably high F1 score, we additionally analyzed differences between two groups, high F1 score group and low F1 score group. We divided the participants into either a high or a low group in order to see what characteristics caused the differences in the prediction of one's subjective well-being changes. As a result, we found there were a significant difference in smartphone usage, such as app usage, phone usage time of the morning, afternoon, and evening, between the high and low groups. Additionally, when comparing their daily smartphone usage time, the high group users tend to spend more time on using smartphones per day than the low group users. This suggests a feasibility of more reliably tracking subjective well-being of active smartphone users than less active smartphone users. Now, I will present some discussion points from now on. In this paper, we had two goals. The first goal was that we wanted to identify the relationship between smartphone passive sensing and subjective well-being. The second goal was that we wanted to find out the time when subjective well-being decreases by tracking the subjective well-being change from smartphone passive sensing. We are now presenting some possible examples from our model research to increase or maintain people's subjective well-being. First, from the results in phase 1, we were able to confirm that location change is not strongly related to subjective well-being, but high ratio of such static activity has a strong negative effect on subjective well-being. With this result, we can provide feedback such as periodically encouraging users to take a short walk, even if not necessarily visiting many places. Second, other types of smartphone features including overall usage time of all apps, phone usage in the evening, and card transactions related to spending are negatively related to subjective well-being. These negative factors can be controlled by notifying users of reducing such usage of phone when the smartphone detects significant increase of them. Next, through the analysis results of phase 2, we have confirmed that our model worked well with active smartphone users, and we would like to emphasize the need for individual feedback. Here are examples. First, user A with 70% F1 macro score showed a significant difference in using the expense app and even phone usage between the increase and decrease. Regarding subjective well-being increase, user A showed more expense and less phone use in the evening. Thus, with this result, increasing reasonable expense or reducing phone use at the time of subjective well-being decrease can be one possible way to improve subjective well-being. Another example is the use of SNS application. Both user B and user C showed significant differences in the use of SNS between subjective well-being increase and decrease. However, the patterns were different. User B showed less SNS use, while user C showed more SNS use at the time of subjective well-being increase. This result again highlights the need for providing feedback based on individual characteristics. We acknowledge that the results of our model are not impressively high enough. Perhaps this is because of the insufficient number of subjective Rhim responses. According to the studies related to subjective Rhim, tracking trends of subjective Rhim requires a sufficient amount of time. So our next step is to collect longer periods and more amount of data. Another limitation is limited study participants. Our participants are mainly university students, so their life and smartphone use patterns may be quite different from populations of other demographics. In our future work, we plan to run user studies with more diverse populations and present a more comprehensive analysis of positive computing through smartphone use. To summarize, many people are exhibiting great interest in and trying to improve their subjective Rhim. This study presents a study of modeling subjective Rhim and identifies salient factors on subjective Rhim from passive smartphone sensing, where people's digital phenotypes can be extracted from their smartphones. So, we hope that our study findings and insights can be further investigated in terms of discovering features relevant to subjective Rhim and improving subjective models, and be applied to realize digital Rhim as part of positive computing research. Thank you for listening.